Then we're going to send that stuff. It's real interesting if you watch those arrows. It's going to go off to do things like cellular energy. It's going to go off to do things like DNA repair. Gee, those sound important, don't they? We would like this all to work. Then, after we've done that, and there's some left over, we're going to use another enzyme to take one methyl group back off. And when we take one methyl group back off, are we going to call it the same thing? No. We're going to rename it, aren't we? Because we're scientists and we're really smart and we don't want anybody to know what we're talking about. Okay? So now we're going to call it 5-methyl tetrahydrofolate. Okay? Then, that has important stuff to do that we'll talk about at some point. But that methyl group that just got freed up, I think on your diagram it's on the arrow going up, it's not around the corner. That methyl group that just got freed up, it hooks right up to the regular old vitamin B12 that you eat, and it becomes methylcobalamin. This is critically important. If this process doesn't work well, we don't make methylcobalamin. And we will have a mountain of regular old vitamin B12 inside our body waiting to be methylated. When your pediatrician or your family practitioner or whoever it is that you go home to and say, but I really would like to try some of these methyl B12 injections, says to you, but look, I measured at LabCorp and his B12 level is fine. You need to be able to explain that you're not looking for regular old B12 to be present and functioning in your kid's body. Your kid isn't making methyl B12, okay? And if they don't make methyl B12, then the whole host of things downstream from this don't work very well. Because methyl B12 snuggles up next to methionine synthase, and it makes the whole rest of this straight across row work, okay? We make methionine, SAM, SAW, and then homocysteine. Homocysteine, gosh, aren't they talking about that in like heart disease or something? Gee, it might be important, mightn't it? So maybe we refer to some cardiology work when we're talking to our docs. Cystathionine is next, then cysteine, and then finally glutathione. Now, if I spent all this time on this diagram, something must have gone wrong, right? Do you think maybe? Head nodding? Okay, would you like to know where so you can like put an X on it? I love that head nodding back there. Okay, where did we go? Are we stuck? No, detoxification, okay, here we go. Let's go right here. See those two X's? One's right there, and one's up here. Put big X's, okay? The first X, and I'm gonna teach you to remember this the way Liz Mumper taught me to remember this. That set of letters is methyl tetrahydrofolate reductase. You can actually do a lab test at LabCorp and stuff for it now, okay? Let me teach you how to remember it. Because I was a sailor before I went to medical school, and I could swear with the best of them. So if you had a few vowels and a couple of other letters in there, and you think about how mad you are that this happened to your child, you got it. Uh-huh, yeah. That one. I drive down the road calling people MTHFRs all the time when they drive wrong. Okay? You won't ever forget it now, will you? Okay? And then it turns out that we also have some genetic vulnerability up here sometimes in methionine synthase. This is a really, really, really important cycle. And when you make it toxic, these are places that give up quickly. We can't make it toxic. We need to be careful about what we're putting inside our bodies so we don't get cancer, and what we put inside our children's bodies so that they don't get autism. And if it's already happened, then we need to clean the mess up. Does that make sense? Okay. Now I'm going to move really fast. All right, so this is where we see all this just, it all happens. So you're going to say to me, so how am I going to explain to my doctor that really there is a problem? Well, this is published in the medical literature. This is from Jill James. And if you look down here at the bottom, what she has is controlled children and autistic children. And their total glutathione, okay? The control kids have 7.6. Our kids have 4.1. Which glutathione level would you like to have inside your body?